Are the slides moving? Can you see the slides moving? Okay.
Yes, sir.
No problem. So we continue, dear students, you are welcome in this class again. We continue with the same topic, response curve fitting. And up to now, we did most of the things manually, calculations particularly. Now, today, you will learn the correlation and regression analysis in Excel, using Excel, how to get the values of the correlation coefficient, how to get the significance of the data or significance of the equations, and test the significance of equation using by F-test, whether it is significant or not, or whether it is linear or quadratic, plotting the equation and work out the optimum economic dose of the fertilizer. So today we will learn all these aspects, particularly how to do regression analysis in Excel. And everyone, each one of you must be having Excel or access to Excel, because it is there in every laptop, every computer. You have MS Office, in that you have Excel. So hope you will be able to understand, but before that, I want to show you the use of correlation and regression analysis in research papers or examples or in interpretation of results. It has very important use there. And many research in the past and many research today's time have been using this knowledge of correlation and regression analysis to present their data. Now, you see, this is just one paper. You can see here, correlation and regression analysis, diversified application in research paper. So this is a paper, impact of ammonia volatilization from broadcast urea on winter wheat production. So now you can see this is how they have made their data in a paper. So you can see they have got two sources, NBPT and urea. Don't go into the meaning of these kind of fertilizers. Just see they are two different fertilizers, NBPT, urea. And you can see the nitrogen rate applied. Nitrogen applied plus soil nitrate nitrogen available. So you can see they have plotted it. On x-axis, you have nitrogen rate. On y-axis, you have grain yield. And this is how they are fitted. The first is representing your NBPT, and the dotted line is representing urea. So here you can compare the response of two sources of fertilizer at different levels. Similarly, on the right side. Now see another case. Same thing. You see nitrogen recovery. You can make any parameter as dependent parameter and any parameter as independent parameter, depending upon your interest. So here you see nitrogen applied and nitrogen recovery. You can put here nitrogen rate. You can put it height of the plant. You can put anything, any character which you like to see the comparison, see the relationship. Similarly, here it is agronomic efficiency. It is decreasing with the increase in nitrogen rate. So purpose here is to see the different uses of correlation and regression analysis. And it makes your paper very attractive. And see, this is optimum seeding rate and stand assessment of soft red wheat. And all these papers have been published in very reputed journal like Agronomy Journal. So you can see different equations were developed and significance was tested, and agronomic optimum seeding rate. For different conditions, for different places, they have worked out the optimum seed rate based upon correlation and regression analysis. You can see the equation. Based upon these equations, they have worked out the agronomic optimum seeding rate, like you have worked out the optimum fertilizer rate or nutrient rate. Some more correlations and regression equations, you can see some more interpretation. So these are regularly being used. So this is another case. This is our own work. So you can see here, the correlation coefficients were developed between different parameters. And what are the parameters, or what are the parameters? Parameters are ammonical nitrogen, nitrate nitrogen, nitrate plus nitrite nitrogen, and we have seen the nitrification rate and nitrification inhibition rate. So many variables you can take and see the correlation coefficients. So here, days after incubation, 7, 14, 21. So you can see at 75 kg rate, the association between ammonical nitrogen and nitrification rate. So it is in negative. If you increase the nitrification rate, the ammonical nitrogen will be less. So it is represented by this correlation in minus 0.99. Similarly, this is nitrification inhibition rate and ammonical nitrogen. So you can see it has positive relation. Mostly, it is all positive relation. That means if you have more of ammonical nitrogen in soil, then nitrification inhibition rate is more. So likewise means with any 2 or 3 variables, we can find out the correlation coefficients. So this adds value to your data, to your work. Similarly, this is another paper, effect of neem oil coated. Hope you have seen these papers. Yesterday I sent you by email if you find time, or you can see as per availability of the time. This is up to you. And friends, this is the paper based upon which our government has fixed the neem oil, or neem oil has put the neem oil coated urea in the fertilizer control order. In fertilizer control order, neem oil coated urea should have minimum of 350 or 360 ppm of neem oil. Hello? The minimum quantity of neem oil in neem coated urea in India is, hello? Anybody? I give twice 350, 360, 365 ppm. Milligram per kg urea. No idea. I think it is 360 ppm. 360 ppm or 350. You can check it. I forgot. So based upon this paper, it was fixed. We proposed that it should be, minimum should be 500 ppm. This is 500 ppm, 1000 ppm, and 2000 ppm. And here I want to show you that this regression coefficients, you see here, regression coefficients can be used to compare the treatment effects. To compare the means of different treatments, the regression coefficient can be used. Suppose your relationship is quadratic, then you will have 3 different constants. One is your beta 0, 100.75. This is actually the mean, mean of the control, 100.75. Beta 1 is your, say, B regression coefficient, and beta 2 is your C. So we can compare the treatment effect based upon these coefficients. So I think you will not be having this idea. This kind of idea is not available. So, but I just want to just expose you that this is also a means of comparison of treatments. You can see here that we have plotted for 2 years on one, the relationship between neem oil per kg urea on grain yield. So we have taken data for 2 years. You can say this is also another way to represent your results. Nitrogen levels versus grain yield, the coating thickness versus grain yield. For 2 years on one chart, you can make it for 2 years. Now, similarly, you can take any 2 variables and see the correlation and make the line like this. So one is N uptake and other is grain yield. How N uptake is influencing the grain yield. So you can see here, it is linear relationship in most of the cases. N uptake, N uptake, N uptake, and then grain yield. So few more papers just to show you the value of this subject. It is very, very important subject. Here you can see the neem oil dose on x-axis, on y-axis you have ammonical nitrogen. And here it is in 4 different soils. So for 4 different soils, you are seeing the results in one chart or in one graph. You can see one is your coarse texture soils, the yellow one. One is fine texture soils, and red one is your medium texture soils and sodic soil, etc. So you can see relationship between two variables is there, and within a chart you can have 4 different equations. Similarly, some variables may have negative correlation, negative relationship. So like temperature, this is temperature and this is mean ammonical nitrogen. As you increase the temperature, ammonical nitrogen is decreasing. Similarly, several variables can be compared. This is the first time we used this correlation and regression analysis in our research papers. Like this. Now this paper is from Agronomy Journal, I think, some big paper, Agronomy Journal. And you can see similar things, different urea and PCU. PCU is polymer coated urea. Polymer coated urea means 2 sources of fertilizer and different doses of nitrogen have been compared. A relationship has been developed. And this is actually quantitative relationship. So one can work out economics also from this. See more such kind of correlation regression analysis. This is also one example. So you can see here, there were 3 sources of sulfur, Kosavet, elemental sulfur, gypsum, and 3 different response equations were developed for different levels of sulfur. And you can see these are the sources, and economic optimum dose was worked out for 3 different sources. So you can see the first source, Kosavet, you require less dose. Less dose was optimum. And also you get a maximum response here. So therefore, in this case, this particular fertilizer was more effective over other sources. And you can see elemental sulfur was better than gypsum. So likewise, this was for wheat and this is for mustard, I think. Response equation, mustard, yeah, rapeseed. So you can see such kind of analysis gives a lot of value to your research paper, to your thesis, and many students have started using it in their thesis work, in their writing of papers. So now,
hello sir.
Yeah, please. Yes.
सर मुझे एक चीज समझ में नहीं आई कि सर इस टोटल रिग्रेशन एनालिसिस में सर लीस्ट स्क्वायर मेथड का सर यूज कहाँ पर है? हम तो सर मिनिमम एंड मैक्सिमम वैल्यू से ही स्ट्रेट लाइन ड्रॉ कर सकते हैं और उसका इक्वेशन भी सर जो वैल्यू दिया है y and x का उससे ही निकल सकते हैं. तो सर लीस्ट स्क्वायर मेथड का यूज क्या है इसमें?
लीस्ट स्क्वायर मेथड से हम एक्चुअली में जब एनोवा करते हैं ना, when we do ANOVA and when we fit the equation, just to fit the equation, for fitting the equation, for developing the equation, we require this method of least square. And we can plot equation where you want 2 values only when equation is fitted. If equation is not there, how can we fit it? How can we plot it? Sorry. How can we plot it? So, and plotting is done for linear equation when it was significant. If it is not significant, then you cannot plot it. And when you plot it, you require only 2 observations, x minimum and x maximum, means y max and y minimum. Y max means maximum yield and y min means lowest yield at control or yield at highest dose. So you can calculate or you can calculate the expected values for x min and x max. And then you can join the 2 points. So that is the next level. The first level is to fit the equation, where you must use method of least square. And once you have found out the equation, then only you can plot it. I don't know whether I replied you correctly or not. Does it satisfy you or you have any further question? I will be happy.
Okay, sir.
I don't know whether
yes,
I can answer it or not. You are free to ask, free to interact. Any other question? This is the time. You can ask any question on correlation and regression analysis. This subject is very close to my heart, and I like this particular subject, and I can help you in learning more about this subject. So anyway, now we go to the Excel part, but we should know the background. What we have, we cannot make good interpretation if we solely depend upon the softwares. Every statistical software will have correlation and regression analysis, whether it is SAS, whether it is SPSS, whether it is any other R software, whatsoever you have. All the softwares have correlation and regression analysis. So, but the students may not have access to SPSS or SAS because they are very, very expensive. So what is left, that Excel is available for everyone. So what we are going to do, compute the correlation coefficient of pair data from the experiment. You know, in correlation regression analysis, we always have pair data. Pair data means you have one independent variable and one respective dependent variable, and there can be many more dependent variable or many more independent variable. We are not going into those complex things, but you know that data is in paired form here. Fitting of regression line. You will see how linear and quadratic equations can be developed in Excel. If you remember how we fitted the equation, linear equation and quadratic equation manually, you remember that, how we worked out the value of ABC or AB. But here, within seconds, you will see how to fit regression equation in Excel. Then we will also test the significance of equation, F-test. For both the cases, we have used F-test, but T-test also can be used to see the significance of the equation. Means whether you have a constant change in Y due to unit change in X, or the changes are different. If changes are different, then it can be polynomial. If changes are constant, then it is linear. So we will see how we can test the significance, means how we can do the ANOVA analysis, and then plotting the equation and work out the optimum economic dose. What we have done manually, now we will do in Excel. So how to start here? Everybody must have seen the Excel. So first of all, your Excel should be there. And in Excel, MS Excel here, in Excel, you have one menu here. If you go on the top of the Excel, when you open the Excel program, File, Home, Insert, and you will find one menu here, Data. And within the data, you have data analysis. Within the data, you will find data analysis. So data analysis should be there. But most of the computers, it is not installed. Most of the computers or laptops, it is not installed. You need to install it. The data analysis is there in the program, but you need to add it to the Excel, add on. You need to put add on. How to do it? You go to the corner, you will find file or some Excel options, something like this. So this is first step, go to Excel options. In Excel options, you will find somewhere add-ins. Add-ins are there. So select the add-ins. And within add-in, number 3 step is select analysis tool pack. You will find analysis tool pack here. And then 4th step is click on the go. Select the analysis tool pack and then click the go. So once you have clicked the go, your data analysis will be installed. So then your computer, your Excel will show you data analysis. And in this data analysis menu, you will have correlation and regression options for all statistical options. Your one ANOVA, one-way ANOVA, two-way ANOVA, correlation analysis, general statistics, and so on. So all kind of statistical analysis performed in Excel will be part of data analysis. So now I assume that you would be able to install the data analysis. So once the data analysis is done, then you can start the correlation and regression analysis or statistical analysis. Now this example, I am showing you how to calculate the correlation coefficient. You can see the formula of correlation coefficient, summation xy upon under root summation x square into summation y square. This is the formula, means you need these kind of corrected sum of squares and other sum of squares. So you see, here we see that one is independent variable, other is dependent variable. This is, suppose this is plant height for any plant, say wheat or rice. This is the plant height, and this is the fertile tillers. This is dependent variable. Suppose the fertile tillers, the tiller number depends upon plant height. Very uncommon kind of relationship. But anyway, we are going to learn it. Assume that one is x, other is y. This is x1, y1, x2, y2, so on. So these data are in pairs. Now you want to work out the correlation coefficient. So this is, I did it manually. So you need to take the mean of x. Mean of x is 87.9. Mean of y is 509. So in Excel, you can calculate, do these manually. In Excel, you can take the mean easily. I think many of you must be knowing how to take the mean of a column or mean of a row. Now you need to calculate the deviation against the mean for independent variable. So mean is 87.9. So 82.2 minus 87.9, 100.2 minus 87.9, you will get 12.3. So this is x minus x bar. You can do it, and sum is 0. And then you see summation y, small y, capital Y minus y mean or y bar. So you see the mean of this column, number 2 column is 509. Subtract 509 from each observation, 495 minus 509 to get this minus 14. 650 minus 509, you get 141. So you can get this column easily. Now, if you square this column, you get summation x square. If you square this column, you get summation x y square, and then summation x y. You have column x, small x, and you have column small y. So multiply these two to get the last column, and then make the total of summation of x square 720, summation of y square 83542, and summation of x by this one. So now you got these, and you know the formula. Summation xy is this value, summation x square this, summation y square this, and you need this. So the value of the denominator is this. Take the square root of this. This is the square root, and calculate the R. So now by putting these values, taking from here, you can get the correlation coefficient. So this is manual calculation in Excel for computation of relationship. This is manually you can do even in Excel. Now we'll do by this software. A field experiment on fertilizer management was conducted on wheat crop, and several growth parameters, yield attributes, grain yield, and harvest index were recorded. Compute the correlation coefficient among different parameters studied in test and test their significance. So in this case, you can see that these are the nitrogen rate. These are the nitrogen rates. And you see these are different variables. So at these nitrogen rates, you need to calculate the correlation between two variables. You want to know the correlation between plant height and fertile tiller, between plant height and spike land, between plant height and next all these parameters. Means you want to see relationship between each other. How this TW is related to GPS, TW is related to HI, means we want to know correlation among themselves. So for any two variables, we will have one correlation coefficient. And how to do it in Excel, you can see it. Now what you need to do is enter the data in the following format and select all. So this is the data. Last slide you have seen. I have shown it somewhat in Zoom. Now you see this is on the left side, you see this is the data, rate of nitrogen and different variables. I can consider any variable as dependent, any variable as independent. It does not matter because correlation coefficient will remain the same. So now how to do it? So number 2 step is click on data analysis. So here On the top, as I shown you, data analysis will be there. Click on this menu, number 2. Number 3, you will see, when you click on data analysis, you will see this menu. So here you select correlation. Correlation is here. You just select it and click on OK. The 4th step is click on OK. Then once you click on OK, you will see this kind of menu. And here you need to click to minimize. Click to minimize the input. Here you see it is input range. Input range means the all data, all kind of data you need to select here. So click here and click to minimize the input. So it will be minimized. After minimization, you select this all data. Select the data. So you have selected the data like this. You can see after minimize, select the data to input range. So this was selected to input range. Here it was selected. After selection of the data, click here, the input range to maximum. Again, you need to maximize it, and then you will have this kind of option. Now, number 3 is click to minimize output range. Here is output range, means where you want to store your results, where you want to see your results. So click to minimize it, output range, click here, and then first you click here, first you click on the output range, then you click on the this menu, output range here. Click to minimize output. Now then you will see this, the output range would look like this. Suppose you want to see output here. So just click here, just give a one click or select 1 or 2 cells, only 1 or 2 cells or 10 cells you select, it will look like this. The output range would look like above after minimizing. Then this is minimized output, what you have seen in the last, and select the space where you want to see your output result. Is it okay up to now? Can you do it manually? I think you must have done such kind of thing before also. Now you can click, correlation is minimized, click OK. So now you will see like this. So input range, you have already filled it, and output range, you have already selected it. You selected this area to get your output. And finally, you click OK to get the result in selected area. This is your selected area. Here the results will come. Or otherwise, you can save your results in new worksheet or new workbook. It depends, wherever you click, you will get results there. Now, the results are, these are the results. You can see these are the results, and this is your data. This is your data. It will look like this. Once you complete, once you have clicked OK, then you will see this kind of data in the Excel sheet. So this is already typed by you before in the beginning, and these are your results. So you can see variables, correlation coefficients between any 2 variables. So here you can see plant height and fertile tiller. Plant height and fertile tiller. And spike length, spike weight, grains per spike, test weight, grain yield, biological yield, store yield, harvest index. So these are the parameters, and same parameters are there on this side. Suppose this is the value, 0.850391. So this is correlation coefficient between, you go up, fertile tillers and between SW, between these 2 parameters. Likewise, you take this 0.738981. So this is correlation coefficient between GPS and between TW. So you can see this looks very fancy, and it is useful also. For example, you see this minus 0.79666, minus 0.79768. This is in minus, and this is stover yield. Stover yield or star yield in minus, and on this axis you see harvest index. So you can see harvest index and store yield are having negative correlation. So likewise, you can find many interesting results from the data by doing correlation analysis. The next job is to see the significance. Certain software will give you significance itself at 1%, at 5% level of significance. they will put automatically stars here, 1 star or 2 star. So that becomes easier. But Excel will not give you the results of significance. It will give you just the value of correlation coefficient, but it will not give you the statistical significance here. And it is difficult to work out statistical significance manually also. So what you can do, you can follow the correlation coefficient tables. Correlation coefficient tables. So here you see number of observations are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here we have used 12 pairs or 12 observations in total. So degree of freedom will be n minus 2. And then at that degree of freedom, you see the table value of R, that is correlation coefficient, which is also critical value of correlation coefficient. So this is shown in full. The same thing is shown in full. And here we have just taken 3 places after decimal. Before, you see, there are many places after decimal, and we have taken only up to 3 places. Because so many places, it becomes very, you just round it off to 3 places after decimal for convenience in reading or understanding. So it has been just rounded off to 3 places after decimal. So this is how you can put the stars. You can put the stars only on the significant. So degree of freedom will be n minus 2 is equal to 12 minus 2 is equal to 10. So at 10 degrees of freedom, critical value of R, that is stable value of R at 10 degree of freedom, you have R tables. At 1%, it is 0.708. Similarly, at 5%, it is 0.576. So you can see, if you want to see the significance at 5%, then the values which are higher than 0.576, you can put 1 star. That is significant at 5% level. So you can see what are the values which are greater than 0.576. You put 1 star. So you can see here. So that is significant. Similarly, the values of correlation coefficients which are greater than 0.708, you can put 2 stars, means that is significant at 1% as well as at 5%. Significant at 1% level of significance and 5. So 0.702, see manual calculations in Excel. Okay. So this is how you can do interpretation of significance of correlation coefficients. Do you have any doubt, any question, anything, any point at this point of time for clarification? Anybody? Anything you want to ask? Is it clear to you? Anyway, so what you can do, you can practice it. Today or tomorrow, whenever you want. I cannot force you, but you can easily learn it in today, tomorrow, whenever. So you put, I will send you, I have already sent you. So you can copy the data in your Excel program and just do the analysis, try to do the analysis. Here you will see critical value of R at n minus 2 degree of freedom, that is 5. So here, if you count, they are 7 in number, 7 pairs. And these are different soil enzymes. So friends, this is your homework, and that you can try yourself and see the relationship between different soil enzymes, acid phosphatase, acid, alkaline phosphatase, acid phosphatase, FDA, DHA, and so on. So it does not matter. Just you see, these are different variables, and you want to see correlation coefficient or relationship between all these. So you can perform correlation analysis. So what we have done, we have performed correlation analysis in Excel. You can try it. If you face any problem, you can contact me through email. So did you find the new table, new slide? Is it moving? The slide?
Yes, sir.
Okay. So this is your homework, and this is the solution of your homework. You can check your solution. And again, one more homework, you can practice more. This is grain yield, and these are yield attributes, different yield attributes. Test weight is 1000 weight, panicle weight, grains per panicle, grain number per panicle, fertile tillers, panicle length, and plant height. So you can see how my plant height, whether the plant height can affect the grain yield, whether the panicle length is influenced by plant height. Very interesting analysis we can do. Only thing is that we need to just think over it, how whether the panicle weight will affect the test weight, and if it affect, whether it is significant or not. So correlation coefficient is very interesting parameter, interesting statistic that tells us many things about our data. Now, today you don't have time. Otherwise, what I used to do here is ask the student to do this in Excel yourself. But there is no time, so you can do it and hope that you come to IRE, then we can do it in class. I used to get this exercise done by students themselves in the class. But now in the online mode, it is not possible. And we are not paying for the Zoom software. So I cannot open Excel also here. I think I cannot open Excel here and show you how to do it. Can I open the Excel here? Do you have any idea? I really don't have. But so far I know that Excel cannot be opened and cannot be worked in Zoom online. What is the status? I tried many times, but I could not play Excel in the Zoom or any other software online. So now you see, we go to the regression. We go to the regression. So same way, we will go do the regression analysis, means just fitting the equations and further analysis. So how to do it? Now, you know that last time we have opened this correlation. Same way you can go to data analysis. In data analysis, you will find analysis tools and you will find the regression. And this is your data. You can see X and Y. X is level of nitrogen or phosphorus or whatsoever it is, 0, 20, 40, 60. And Y is 3, 3.8, 4.2, 4.9. So these are four values of the dependent variable. Here I wish to tell you that in most of the circumstances, we do not take replicated data. We take the mean values here to do the correlation and regression analysis. Here in our case, we take the mean values. So these are the mean values across different replications. First thing. Second thing, when you are doing correlation and regression analysis, at least 4 pair of observation should be there. At least 4 pair of observation will be there. If you have less than 4 pair of observation, then it is not statistically sound, it is not statistically correct. If you have more and more pairs of observation, then your accuracy, precision, or statistical significance will increase. So we should have more and more observations, but minimum set of observation of pairs should be 4. Please remember this. And tomorrow I will answer it, why we should have minimum 4 pair of observation, particularly when we are fitting quadratic equations. Or if you find answer, or if you know the answer, you can tell me now. Okay, you may not be knowing because this is new subject to you. So now you have selected the regression. And same way, this is your X independent variable, and this is your Y dependent variable. So input Y range. Here Y means the dependent variable. So this is your dependent variable. So you need to just minimize it. Minimize it and then select all these, including Y, 3, 3.8, select all these. Even the alphabets you can select. So here, and then you again minimize it. So this is your input Y range, because you need input for Y, input for X. Next is, you can do like this, select the Y, maximize the input Y range after selection. And now you need to input X range. Once you have done the first, second is X range. Same way you can do it. Click to minimize the input range, and then you can select X. You can select X and then again maximize it. Maximize the input. After minimize, select the data to input X range. Then again output range like you have done in correlation analysis, and you can click on the labels also, because in the first row you have labels, LABELs. Labels are your non-numerical values, X and Y. These are your labels. So if you click this, it will not consider them in the analysis. So tick on labels in first row. Second, click on the output range. Now you want to select the area within the Excel sheet where you want to see the results. Just minimize it and select the area in the sheet, and again you can maximize it. So you can select the area like this, select space, already discussed with you. Now you can see this. Finally, you will see this. Your input Y range, you have done it. Input X range, you have done it. And then labels also you have ticked it. And then output range, where you want to see the results. And you will see something more here. Residuals, I was discussing you about the residuals. Means observed data minus predicted data value. That is your residual. It is your error also. So if you want to see residuals, you can tick it. If you want to see residual plot, you can tick it. If you want to standardize the residuals, this is for IASRA people. They want to standardize further analysis of residuals, fit line plots in residuals. So many options are available for residuals also. You can tick them if you are interested, otherwise not. Then finally, you see all these parameters have been fulfilled, and now you click OK to get the results. So now you will get the regression analysis results. So here are the results. It will look like this. If you do this regression analysis, in Excel sheet, you will find these results in this form. First is multiple R. This is your correlation coefficient. Multiple R, here just forget about multiple, nothing to do. We have taken only two variables. So this is our simple correlation coefficient. So this is R is your correlation coefficient, and the value is 0.992822. And if you square this, you will get 0.985695, means R square. You multiply it by 100, that means 98.5% variability in Y has been accounted by the X in the regression equation estimated. You can see here, adjusted R square is not for us. This is not required, and observations were 4. Okay, so this is clear to you. Now you see ANOVA, analysis of variance. Because for regression, degree of freedom is fixed. It is 1. It is linear relationship where you have X is 1 or power of X is 1. So 1 degree of freedom is fixed here. For quadratic relationship, you will always write 2 here. For cubic, you will always write 3 here. Okay, so this is fixed. And total is also fixed. Total is n minus 1. N is number of pair of observation minus 1. So 4 are the pairs. So 4 minus 1, it is 3. And this is by difference method. Means total minus regression degree of freedom. So 3 minus 1, you get 2. The sum of square value has been calculated. And if you remember, we did it manually also. You can do it manually, you will find the same results. So this is sum of square for regression, for residual or error, and then total sum of square. This is summation Y square, if you remember. Then mean square, this value divided by degree of freedom. So you get mean square values for regression. This is your actually variance, and variance 1, and this is variance 2, error. And this is F calculated. F, you know, it is ratio of variance 1 and variance 2. So the value of variance 1 is more. It is kept as numerator, and variance 2 is less. Then it is kept as denominator. So it is ratio of variance, which is 137.8. And then significance. You see, it is significant at 0.7178%. Or what you need to do, you multiply this significance. This is probability level multiplied by 100, it is 0.71%. So it is significant at 0.71%. That means it is significant at 1% also or at higher levels. So minimum level of probability for significance is 0.0071 multiplied by 100. So you get it significant at 0.71%. Level of significance, it is significant. Therefore, it is surely significant at 1% level of significance. This is the analysis you need to, means understanding you should have. Then you want to fit the equation. This is your equation. Coefficients are given. This is the value of E. A, you can see intercept. Intercept, this is 3.06 is your intercept. And this is the regression coefficient. This is the, so put the value in the equation. This is A and this is B. So this is your equation from Excel. Forget these values. Or otherwise, you can see one interesting thing here. This is your regression coefficient. This is your regression coefficient. And see the p-value. P-value is 0.007178. So that means it is significant. It is significant at 1%. Means the equation is linear. Here itself, it is proved that equation is linear because you are testing the significance of the regression coefficient. So the p-value is 0.0071. I'm sorry. This is p-value. I'm sorry. This is p-value 0.019321. So that means it is significant at 1.93%. Or you can say it is significant at 2%. It is significant at 5%, but it is not significant at 1%. So this will tell us the significance of F. Do you have any question from this or up to now? If not, okay. Now residual output, you can show the residual output also. And this is your X, 0, 20, 40, 60, you remember. And these are the observed value. You have seen Y, 3, 4, 3.8 and so on. And these are predicted value. These are given in Excel, or you can do it manually also. You have the equation. This is your equation. If you want to know this value, then you put 0 here. You will get 3.06. If you put 20 here in place of X, you will get 3.67 as the predicted value. If you put 40 here, you will get 4.28. So these are called as predicted values. We get it from equation, and these are our actual values. See the difference in these two. Y minus Y, capital Y minus small y. This is minus 0.06, 0.13, 0.08, 0.01. So these are your residuals actually. You can see they are very small values. These are actually errors. So plotting the equation, I think I can continue tomorrow. Or how much time is left? I think we have 5 minutes more, 7 minutes. So see, plotting the equation. I don't know whether you could understood it or not. If you could follow it, then I can move forward. Should I move forward, or you have any question from this? This is very simple thing we started here. If you have any doubt, your homework, and then from here we started. You can see. This is your data, K application and your yield. So this data is fed here, you can see. You can select the regression, then input Y range, input X range, and so on. And we did all this, and in the end, you found this. This is you get in Excel, and you can see the correlation coefficient, regression coefficient B is significant here. And you also found R, you also found R square. So R square is 98.5, 0.985, and so on. Hope you understood it. Now we go to residual plot, residual output, and now we see plotting the equation in Excel. You can do it in Excel very easily. This is your X, this is your Y, same values. You select the data, select all data, and you go to the insert. Go to the insert, please see it. Go to the insert option, and then in insert option, you will find something like that, scatter plot. So just click on the scatter plot here, this form, scatter plot. And then you will get the plot like this. This is your scatter plot. This is your X, different levels of K, and this is your yield, Y. So 4 different points are there. Now you select on this point, click on any one point, and then all the 4 points will be selected because you are plotting the line. So you have selected, you see, it will look like this after selection, and click the right click. I think you know right click. Right click, you will get these options and add the trend line. Click on the add trend line. After click, you will see like this. On the right side, you will see this menu. And there are many options. Which kind of equations you are going to make, whether it is exponential, linear, log equation, polynomial, power, moving average, variety of options are available. So if you see the data scatter plot, if it looks like a trend line, a straight line, then you can click on linear. Just click on linear. If you want quadratic, click on polynomial, click on 2. If you want cubic, click on 3 here, 4, 5, you can select. And then you can select display equation on the chart. If you want to see equation on the chart, click here. And if you want R square value on the chart, click here. So once you can click on the both options and your equation will look like this. You can see on the left side. So here your equation is there. Within seconds, you found your equation. So this equation you can find this way also and that way also, where you gone for regression analysis. So that is your detailed analysis. This is your detailed analysis, this, where you get sum of square, mean square, and finally you get value of A and value of B. But here also, using the trend line, you will just get the equation. Here you will get the same equation you will get, and also R square. So this is how you can make equation. You can have another column. Here, say, suppose this is Y1, this is yield from one source of fertilizer, then you can have yield from another source of fertilizer, or you can have variety 1, yield of variety 1, yield of variety 2, yield of variety 3, yield of variety 4, and put the data and make all the 4, 5 lines on the same graph. I think now this is an example for you. Soil pH and Olsen P. Relationship between this you need to develop. Perform the regression analysis. You enter the data. In data, you will find data analysis. Go to regression. Enter input Y range. Then enter input X range. Select the area for data output where you want to save your output. Click OK to get the ANOVA and other details. So this exercise also you can try. This is another exercise. I have given the summary of the results. You will get these kind of results. You can do yourself. And you can see the relationship between soil pH and Olsen P. So you can see this is negative relationship. This is a negative relationship. So fitting quadratic equation in Excel, I will teach it tomorrow. It's a right way. I will start from this point so that time can be saved. So this is how you try this. This data, you see soil pH is X, independent variable, and Olsen P is your dependent variable. Just assume. And then at 8.5, you have 6. So here pH is decreasing. Here the phosphorus is increasing. So you can have negative relationship here. So I end this presentation here. And now your questions are welcome. I think we still have 1 minute time, or you can send me your question by email. I can share with all. So you can have quick questions, any question you want to ask. No question, then your attendance. You are 20 people. See, my background is very interesting. It looks that I am sitting in the sky. Is it like this, behind the stars? My background, it is mistake of the camera, I think, some camera problem. My teeth, you can see, they are just shining or looking like your silver teeth. Eh? So get relaxed. Thank you. Bye.
Thank you so much, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.